Okay, so here's a little bit of help with standards-based writing too. We've been working with inequalities. So writing inequalities, finding the solutions to inequalities. We've been working on systems of inequalities where the area that is shaded by both inequalities is the solution to the system. So this is an example of that. We have a problem that says the boys and girls soccer clubs are trying to raise money for new uniforms. The boys soccer club is selling candy bars for $2 a piece, and the girls soccer club is selling candles for $4. They must raise more than $800. Here are your steps. Define the variables. What will be X and what will be Y? You're going to write an inequality to express the income from the two fundraisers. So in this part, you're going to deal with the money aspect. The girls expect to sell at least 100 candles. Write an inequality to represent this situation. Then it says use Desmos to graph your equations. So actually I put in here a graph so that you can show your work. Now, if you're thinking, I really don't know how to graph this, that's okay. In here on slide 2, I've given you a graph where you can put in your equations. You can click in that box and type your equations in. So that's the part that says use Desmos to graph your equations. If you're doing this in D2L, you can use the Desmos graphing calculator, which is linked in your assignment, and you can attach the graph to your work. There's a share button up in the top right hand corner of your Desmos graphing calculator screen, and you can paste that link directly into your work. The last part is give 2 possible solutions to this system and justify your answer. So, first part is define your variables. What is your X going to be? And what is your Y going to be? So, on this, I'm going to call candy bars X, which means candles is Y. It's not technically candy bars. This is the number of candy bars sold. So Y would be the number of candles sold. That's defining your variables. You don't need to do anything more than that there. That tells what each one stands for. The next blank I have here is the inequality for the girls' soccer club. It says the girls expect to sell at least 100 candles. So we're looking at selling at least 100 candles. So my variable here is going to be Y. Actually, I'm going to erase that. I'm going to use this little math button here where it says type math. And then I'm going to do Y. And we want to sell at least 100. If we're selling at least 100, we could sell 100, we could sell 120, we could sell 500. At least means 100 is the lowest, which means that we need the sign of greater than or equal to. And that number that we wanted to be over or at was 100. That's all you need for that inequality. The next thing I'm going to do is graph this equation. y is greater than 100 is going to be a horizontal line at 100. Then for the inequality part, you have to decide, and I'm going to leave this to you. You have to decide whether you're going to shade above the line or below the line. So think about what greater than would be, and you're going to shade to whatever side of the line that should be. The next step is writing the inequality for the income. So think about this. We're selling candles for $2 a piece. So if we sold 2 candles, we're making $4. If we sell 20 candles, we're making $80. So we're taking the number of candles and we're multiplying it by, not candles. I keep saying fine, I'll keep with candles just because my brain wants to go there today. Candles are $4 a piece, not $2 a piece. Sorry, I messed that up. So we're going to do 4y. And I want to hit that math button again. We're going to do 4y, because that's 4 times the number of candles, plus 2 times the number of candy bars. And we need to make more than $800. More than. So think about what sign that would be. $800 is the lowest I can go, but I can't include that because I need to make more than $800. I could make $800.50. I could make $900. We just need to make enough to cover the $800 requirement. The next part is to graph this. So I have the graph option on the next page. If you're not sure how to graph this, that's okay. Type it in to Desmos. 4y plus 2x is greater than 800. If you don't see anything on your graph, you're going to drag it, and then you can zoom out, drag, zoom out, drag. There's a plus and minus button over here on the right side. That's your zoom button, unless you have a scroll wheel. That's how I do it so quickly. So that's what that would look like. Then you're going to have one for your y is greater than 100. So make sure you have that. This work area here we can use for multiple things. If you're going in here and you're trying to figure out where to plot your points for this, you can test a couple. Okay, so I want to figure out this 4y plus 2x is greater than 80 or 800. 4y plus 2x is greater than 800. So if I pick a couple points, I can find my intercepts, I can find my x-intercept, and I can find my y-intercept. If I plug 0 in for x, I get 4y is greater than 800, which means that our y-intercept is 200. All I'm doing is finding my intercepts now. There's one of them. Then if I did the other one, I get 2x is greater than 800. I'm even ignoring the greater than sign right now whenever I'm going to plot these, because I'm really just looking to see what happens when x equals 0 and when y equals 0. So when we divide both sides by 2 here, we get 400. So our x-intercept, when y equals 0, that's what we have. And then because this is greater than and it doesn't have the equal to sign, this would be a dotted or dashed line for this point. Then you have to decide, are you going to shade above the line or are you going to shade below the line? So think about a point that works for that. So x is greater than 400 and y is greater than 200, so everything that fits that would work. Your next task is to give 2 possible solutions to the system. So remember, anywhere that is shaded by both equations or both inequalities is a solution to your system. So let me go in here real quick. So if I had, let's just say I had this, y is greater than 20 and x is, actually let's go 3x minus 2y is greater than 40. Let's say that those were our 2 equations. They're not, but let's say they were. If these were our solution, if these were our equations, we would come through here and we would see that anything in this shaded region, and if you want a table, you can hit this plus button and hit table, and that'll get a table up for you. So I'm going to pick a test point. Let's say 30, 20. Now, we talked about this in class, but where this is on a dotted line, yes, it's in the red area, but it's not in the blue area because that's a dotted line, so that couldn't work. Okay. Same thing. If it was on this red dotted line, it couldn't work. But if I go somewhere like 50, 30, where it's shaded by both, it's shaded by the blue right there, and it's shaded by that red area. If you look, it's shaded by the blue and shaded by the red. That's why it works. This one here, like I said, doesn't work because it's on that dotted line. So think about that whenever you're going to graph this. So whenever you go to think about your solutions, think about, excuse me, whew, yawns get me. So think about that dotted line versus that solid line. You're going to give 2 possible solutions to your system. So that double overlapped area, and tell how you know. If you took them and you plotted them, if you made your graph and then you plotted your points and they fell in the area that was double shaded, tell me that. If what you did was came in up here and you plugged in your x and y values into these equations and they come out to be true, tell me that. How do you know that your solutions are in fact solutions to the system? That's the question here. Okay, so I hope this helps. If you need any more assistance, let me know. I will get these graded as soon as I can, so you get that feedback, and I look forward to seeing you in class.